Everyone, this is the second part of the video and we are discussing spatial graphs, and we have discussed these two property, and this is necessary for further discussions. And the next graph that we have is complete graph. And it is denoted as Kn. Okay, so what is the definition? At first write Kn. What is the definition? Simple graph, obviously simple graph with no self loop and multi edges, having max number of edges. Or there is another definitions: every vertex is adjacent to everyone. Okay, this is the definition. Now example. Okay, I'm just starting from one vertex K1. This is only one vertex, so there is no problem with that. K2, two vertex, and you can see this vertex is adjacent to this and this vertex is adjacent to this, so every vertex is adjacent to each other. Next K3. Okay, so what is K3? Three vertex and every vertex is adjacent to each other, like this adjacent to this and this, every vertex is adjacent. Okay, K4, four vertex. Okay, now these two are not adjacent, make them adjacent. These two are not adjacent, make them adjacent, like this. K5, having five vertices, and make all the pairs as adjacent pair, like this. Okay, now see the table. This is known as Kn, and number of vertex is n, because n. And what is the number of edge? Like we have said, the max number of edges in the definitions. And what is the max number of edge in the simple graph that we have discussed earlier is n into n minus 1 by 2. And you can match with the examples. This is one. And what is the degree of vertex? Like just say K3, there the degree of this vertex is 2. Every vertex is same. The degree of every vertex is same, and that is n minus 1. And you can see that we have said that the max degree of any vertex in simple graph is n minus 1, where n is the number of vertices. So when a graph containing these two properties, so that graph is called complete graph. Okay, this is the all about complete graph. And there is another special type of graph. Let me change the page. That is n cube. You can write it as Qn. Okay. So this graph is very special, and this is denoted, this contain 2 power n number of vertices. Okay, like if we are discussing with Q2, this having 2 power 2, that is 4 vertex. Q3, that is 2 power Q, 8 vertices. Okay, and for this case, every vertex is denoted with one binary string, and two vertex can be adjacent if and only if there must be difference between the edges is 1 bit. only one bit change. What is it? This will be clear after seeing example. Like if we are discussing with q2, so there is 4 vertex, okay, and we know for rectifying 4 numbers we need 2-bit binary representations, okay. So this is 0 0 0 1 1 0 and 1 1, okay. Sorry, let me take it 1 0 and this is 1 1, okay. Like see, the 4 vertex is denoted by 4 binary numbers, and look, this and this vertex is adjacent, okay, because look, this 0 is changed by 1, so there is change of only 1 bit. Next, this and this is adjacent because only 1 bit is changed, okay. This and this vertex and this vertex are adjacent because only this and this is changed, and last but not the least, this and this is adjacent because this 0 is same, just changing the 1 and 0. Now look at this, we don't make these 2 vertex adjacent because we can see there is difference of 2 bits here. We can see here also these vertex and this vertex, these 2 are not adjacent because there are 2 bit difference, and this is denoted by q2. And let's see q3 as well. I am just drawing it, okay. So how many number of vertex? 2 power 3, that is 8. So we can see there are 8 vertex, 1 2 3 4 5 6 7 8, okay. So we can represent them like this: 0 0 0 0 0 1 0 1 0 1 0 0 0 1 1, okay. So and this thing we can write as, I will explain how I am writing these things. 1 0 1, and this thing we can write it as 1 1 1 and 0 1 1, okay. I think this, sorry, 1 0 1 1 0, I think this much is okay, like we have to see, okay. So 0 0 0 and 0 0 1, there is difference of 1 bit here also 1 bit, and this, there is the difference of 1 bit here and here, and we can see the further, like I am just doing one more, 1 0 0 1 0 1, so difference of 1 bit here and here, that's why these 2 are adjacent like this. So before drawing the table, we must know one property of graph theory, that is known as handshaking lemma, okay. Handshaking lemma, you have to know this after before doing that state the summation of degree of vertex is 2 into number of edges, okay. So this is the thing. So for this case, okay, so you can see for q3 the degree of every vertex is 3, for q2 degree of every vertex is 2, so the degree of every vertex is n only. For q3 3, for q2 2, okay. So summation of degree of vertex means degree 1 vertex plus degree 2 vertex plus degree 3 vertex and degree of n vertex, that is equal to 2n. And what is the number of vertex we have? We have 2 power n number of vertex, so we can see write it at 2 power n number of vertex and having n degree of each. okay, and that is equal to 2e. So what is the number of edge present here? 2 power n into n by 2, that is 2 power n minus 1 into n. I think this much calculation is clear for everyone. Now we can draw the table. That is graph, vertex, edge, degree of vertex. Okay, so this is denoted as Qn. What is the number of vertex? That is 2 power n. What is the number of edges? We have calculated 2 power n minus 1 into n. What is the degree of every vertex? That is n. We have discussed earlier. Now we have to, now we will go on to next graph that we have is regular graph. Okay, and what is the definition of regular graph? A graph having all vertices with same degree. Okay, every vertex having same degree. Okay, and we can write it like that: for all vertex, degree of vertex is k, like every vertex having the same degree. And for if one graph having all the vertex having degree 2, so we can say that 2 regular graphs. For k, it is known as k regular graph. Okay, now we will see some example. Okay, we have discussed null graph earlier. So what is null graph? I'll just show what is null graph. Null graph having, we can see every vertex, the degree of every vertex is 0. So null graph is also one kind of regular graph, and what is called zero regular graph, because every vertex having the degree 0. Next we have cyclic graph, where every vertex is having degree 2, so this is 2 regular graph. We having kn or complete graph, okay, where every vertex having n minus 1 degree, so n minus 1 regular graph. Okay, so this is regular graph. Okay, the next thing we have bipartite. Bipartite graph. Bipartite graph is simple graph. So bipartite graph is a simple graph where every vertex can be divided into 2 parts. Every vertex can be divided into 2 parts or 2 sets, where every edge is adjacent to every edge belongs to set 1 to set 2. Let me clear it again. So bipartite is a one kind of simple graph where every vertex can be divided into 2 sets, and where each edge is from set 1 to set 2. Like, see some example. Like for this graph, v1, v2, v3, v4. So if we divide it like this, okay, so vertex set 1 content v1, v3, and vertex set 2 content v2, v4. Like, now see every edge, like this edge is from vertices 1 to vertices 2. This edge is from vertex set 2 to vertex set 1, like that. So this is one bipartite graph. Okay, now you can write like this. Can we divide it in some parts? Like if you divide this like this, so this edge is in one set, so this is not the right partition. This is also not right partition, because this edge is only between that set, this part is not, so this is not bipartite graph. Now I am writing one property that is very necessary, and the property said that a simple graph is bipartite if and only if every cycle present in the graph is even cycle. Okay, like this is a even cycle because this is actually C4. So this is actually C4, that's why this is bipartite, but this is not bipartite because it is a C3 and that is odd cycle. Like we can write it like this. So this is one bipartite graph because this cycle, in this graph there is two cycles present, 1 and 2, and this cycle is C4 and this cycle is C6. We can see 6 vertices. Okay, that's why this is bipartite.